Good evening. I am here to present my EDA and Python assignment for topic 8. I decided to do some more space data because it's really interesting to me. So the data set that I downloaded was actually, I found on Kaggle, and then through reading the summary realized, well, this one's 6 years old, and they gave us a link to the updated Kepler dataset. So I went to the Kepler exoplanet website and downloaded the most recent data that was updated today. So this is very recent data and quite exciting. It had thousands and thousands of rows. So cleaning that up was really interesting and kind of fun. Anyway, here we go. So I started by just exploring the data, looking at it, getting some summary stats. I realized that one of these columns was practically empty, so I went ahead and deleted that. That was the Kepler name column. I think you can see that here where it's got, 6,820 empty rows. So it wasn't really worth keeping. And plus it was just a category. It wasn't really, that important. There's many, many other ways to identify these items. So carrying on with that, got some Booleans in here that we get to use, and those are pretty fun. So carrying on, I just started making some visualizations between variables, trying to figure out what I wanted to look at. So there's a few of those. I came up with 3 research questions and 3 hypotheses. I decided to stick with this middle hypothesis here. Confirmed exoplanets tend to have specific ranges of orbital periods and impact parameters that distinguish them from false positives and candidates. So rolling with that, I just started exploring. This was me still trying to figure out which one I wanted to use. So I went with hypothesis 2 just because it had a lot of different variables and a lot of different relationships that looked like we could explore. So I wanted to just kind of see what was out there. So exploring hypothesis 2, I did threw it back to chapter 6, did a Mann-Whitney U test on this KOI period and KOI impact to see if those parameters with the confirmed exoplanets and false positives were significant. So the p-values are practically at 0, which rejects the null hypothesis of it being, having no difference. So then I went ahead and I cleaned up some data because I did realize that we had a lot of outliers. I made a chart, which I kind of wish I had left it in here, but there were some wild looking outliers. So I went ahead and took those out, and I actually ran the test several different times with and without outliers just to see if there was a big difference, and there wasn't, which was great. So I did a logistic regression model to predict the confirmation status of the KOIs based on KOI period and KOI impact to demonstrate moderate predictive ability. So you can kind of predict here. I believe there's a percentage more toward the bottom where it's 65 or 67% accurate. I did a multi-collinearity check, and there's no concern of multi-collinearity between these 2 variables. And then I did some data visualizations just to further explore these things. We've got an ROC curve here. There is a heat map confusion matrix. Oh, here you can see the model distinguishing between confirmed and non-confirmed Kepler objects. So that's what that one was. True positive rates and false positive rates. And then this one to represent the regression model predictions. And then here we have the impact parameter by KOI status, and then the orbital period by KOI disposition status of confirmed and not confirmed. So comparing these 2 with false positives, it helps to visually, validate what we think is going on. So really in conclusion, we can basically just say that, these findings highlight the importance of those characteristics in exoplanets. The orbital characteristics is really important in exoplanet verification. So that's my report. I'm running out of time. Here's all my sources. Have a great night.